So dots, yes, the difference of two squares. This is far and away my favourite formula. Dots. Simple. Let's have a look at these two brackets. X plus y, x minus y. And if we multiply them out slowly, using my method, x times the second bracket, y times the second bracket, we see we get x squared minus xy and yx. Yx and xy are the same, so they're going to cancel out, and minus y squared. So that shortens to x squared minus y squared. In other words, x plus y times x minus y is equal to x squared minus y squared. We normally look at it this way around. This is more the way it comes up in questions and things. The difference of two squares, one square subtracting a second square, is equal to the first plus the second times the first minus the second. Absolutely brilliant. Simple, attractive and useful. Let's see if it really works. 5 squared minus 3 squared. So now x is 5 and y is 3. So this is 5 plus 3. This is 5 minus 3. Well, 5 squared is 25 minus 9. Okay, and this is 8 times 2. 25 minus 9 is 16, and 8 times 2 is 16. That's a relief. Does it work every time? 10 squared minus 1 squared. Here x is 10, y is 1. So we have 10 plus 1 and 10 minus 1. And over here we have 100 minus 1. And here we have 11 times 9. 99 equals 99. Looks pretty good. Let's see if it works with variables. Well, I suppose we have to assume it does, because we're not going to put values into these variables. X squared minus a squared. So here we've still got the x squared, but we've got a squared where we had y squared. So when we come to this bracket, we'll replace y with a. So we have x plus a, and then x minus a. X squared minus 100. Well, this sort of sticks out that this is, in fact, 10 squared. So here we have x squared again, and now y is replaced by 10. So we have x plus 10 times x minus 10. B squared minus 25. Again, 25 is 5 squared, so b squared minus 5 squared. So now we've got x is replaced by b, y is replaced by 5. So we'll have b plus 5, b minus 5. These are actual questions from an exam. X squared minus 64. Factorise it. You can freeze the video if you want and have a crack at this yourself. But if you're in a lazy mode, I'll give you the answer. There's the 64. $64 question? $64,000 question. Is that a square? Well, yes, it is. It's 8 squared. So this is a difference of two squares. We've got an x, we've got an 8. So we've got x plus 8. X minus 8, and that's factorised. Second example, again, if you wish, you can freeze the video, pause and practice, or you can just wait a moment and I'll give you the answer. K has replaced x now, and that's 4 squared, isn't it? K and 4 squared, so y is 4, and we're going to go with first plus the last times the first minus the last. Yeah. And this is how I remember it. When you see the difference of two squares, it's first plus the last times the first minus the last. In this case, we've got 81, which is of course 9 squared and p squared. So we've got the first is 9 and p is the last. So first plus the last times the first minus the last. That might help. It's a memory aid. I don't know what's going to happen. Oh yes, here we go. To summarise, I remember it this way. I think it's quite attractive. I think it's easy to remember. X squared minus y squared equals x plus y times x minus y. But some people like to remember things in words. So the difference of two squares equals first plus last times first minus last. I hope that helps. I think this question, if you don't know it, is incredibly difficult. Factorise x squared minus y squared. Where do you even start? But once you know that formula, it becomes a bit easier. Still tricky, because you've got to recognise whether these are squares or not. But it's a fantastic tool in your arsenal. So why not subscribe? Stick with us. There's loads of videos already and there's more coming. If you're taking in a maths exam, best of luck.